The Matterhorn was designed around the specifications that we were given by the military. They required a source that would produce somewhere between 94 and 104 dB, between 15 and 20 hertz at a distance of 250 meters. They also had a physical size limitation that they were shooting for, which was a shipping container, a standard seagoing container. The military has been working on whatever this project is for several years, and the approaches that they've taken so far haven't been satisfactory.
The reason why we built the Matterhorn was it's a chance of being part of history. There's never been a sub like this built on the planet that we're aware of. And Tom's background with having helped with a sonic boom generator and whatnot over the years, he's pretty much recognized as an industry leader in subwoofers. So this was a neat opportunity to build something that just had never been done before. We did it because we can. When I approached the design of the container speaker here behind me, it appeared that the tapped horn was the only design approach that would work in a size that they would accept. The tapped horn is a new low-frequency horn configuration that uses the radiation from both sides of the cone. So while you see 40 speaker cones in the model behind me, we're actually using both sides of all of those radiators. Basically, we couldn't have done this in this physical size using a conventional horn or any other approach that I'm familiar with. People will say, well, what in the world would you use this thing for? I mean, who in the world would buy this? Well, obviously we're talking about some military applications, but there's also things like avalanche control, something that Tom has actually had some work with in the past. Everything that's used now is typically explosive type materials. This allows us to actually modulate a hillside.
We probably could use it for the ultimate boombox. Let's cut that.
Another possible application for the Matterhorn is in weather sensing testing. Tornadoes are sensed by using low-frequency sensors. It turns out tornadoes make very low-frequency sound that can be detected many miles away. And that's turning out to be an effective way of warning people about tornadoes. Those low-frequency sensing systems, though, need to be tested, and you need to have a source, something not as powerful as a tornado, but you need a powerful low-frequency source to simulate that and to test and align those systems.
We see the Matterhorn not only being used in military applications, but also in commercial sound applications. One container sub will be able to do any venue on the planet, indoors or out. It will go significantly lower than any commercial sub on the planet. Logistically, we cut probably at least one semi, if not two, out of a major tour. So it's actually an economic thing. And because it's a mathematical relationship, we can scale it down, so we can make smaller versions of this that actually will do extremely high power applications, and we can contour it for a specific need. They may not want it to go to 15 or to 12 hertz, but we can cut it in half and it'll go to 30 and 25.